It's a pleasure to be back in Delhi. It's an honor to be here and talk to you. It's a little bit intimidating for me. I'm an Army officer, or I was an Army officer. I'm on a panel with two naval officers and one colleague of the Army. So this could be the Army-Navy match, if you want. There's also a challenge because I felt compelled to make sure my presentation did not only address land operations, ground combat. So I've had to learn that you can't just say map, you have to say chart when talking to the Navy. The theme of this session is about geographic coordinates and enabling navigation, which is an interesting topic. And to begin with, I wondered exactly how to address that and make sure that what I was going to talk about was relevant. And I think I've actually done that. And I think maybe some of the questions that were asked from the previous speaker, from Todd, I might be able to help with. What I'm going to talk about in general is the need and the provision of authoritative and relevant information to enable national security. So not just the armed forces, but true national security. So, as our distinguished guest this morning said, national security is a very complex endeavor. It involves multiple agencies, multiple missions, in complex environments. We all know this, we all see this. This is the essence of the challenge of national security. The solution has to be unity of action. We had September the 11th because we did not have information sharing and unity of action. We actually had the Boston Marathon event because of the same reasons. So it is hard, it is challenging because you have to bring together many different participants in national security. And it's no accident that the first agency on this list, on the left-hand side, is the National Mapping Organization, which in many cases, for many folks, would actually be the National Hydrographic Organization. To me, they're synonymous. It's about the foundation data on which all the rest of the participants will then be able to conduct their activities. So what we have to solve is a multi-agency problem and provide a multi-agency solution. We also heard, and I think we all acknowledge now, that geography is the integrating framework for our activities. Whether it's activity-based intelligence or whether it's any of these missions, the common framework that everything has is place and time. Even cyber is geographic. Everything is owned by somebody at some place at some time. The power of geography, the power of geographic information systems is the ability to bring in multiple intelligence types and fuse that information so that you can tip and cue between those different data sets. And you can see now that open source intelligence, such as Twitter, social media, is now a valuable source in trying to predict the unknown. So the vision today is to empower everyone. This is not just about the geospatial professionals. It's about empowering people to access information, to use that information, to share their intelligence and their results, to contribute that in an online environment, and to do that and provide that on demand. And whenever I say online, I don't always mean the internet. In fact, for most of our community, that would be behind your secure firewalls. So whenever I say online or web, I usually mean on a classified network. And we have to create this culture of collaboration and information sharing. But I want to go back and pick up on the Admiral's comment about some of the dangers of not understanding geography and why this is not always as easy as it seems. So 3 examples. The Falklands War. No one was ever going to fight a war in the Falklands, so when they mapped it, it happens to be on the junction of 2 grid zones. So when we came to map the Falklands in the British Army, we had 2 grids, and they were not perpendicular. If you've ever done fire control and artillery, taking out the join, it's really hard to conduct operations on 2 islands with 2 different grids. So we had to manage that problem. We overprinted the maps, and then we had to choose the grid we were going to use. When we went to Desert Storm, Most of the maps that were used by the ground forces used the European date M50, but all the Apaches were on WGS 84. There could be a difference in sometimes over a kilometre. Think what would happen if somebody reported an enemy unit, provided that to an Apache, and they went to that coordinate. They wouldn't find the enemy, but what would happen if they found friendly forces? We'd probably have fratricide. And even as recent as Bosnia, my last assignment with the NATO headquarters, the Serbian forces used maps that were based on the Hermes-Kogel datum and the Bessel projection. Well, everybody in NATO used WS-84. So when people came to us with Serb intelligence and said there's a mass grave here, or there's an ammunition depot that you need to go and see there, and we plotted that, there was nothing on the map. Once we realized we had to do datum transformation as well as coordinate conversion, all of a sudden we were finding buildings, we were finding places where bodies were buried. And it doesn't end. We're in the world of web mapping. Google's made it easy for everybody, except you still need to understand datum, ellipsoids, and grids. It doesn't go away. I do not speak for the National Geospatial Intelligence Agency, these are my own views, but I'm going to use some slides they provided. So when we look at Google, when we look at most web maps, we're actually using a web Mercator projection. Who cares? Visually, they look the same. But actually, the web Mercator is a spherical-based projection. It's based on a spheroid, not an ellipsoid. Hopefully, most of you don't need to know what that means. But if you don't have people in your organization who do, then you can actually have a mislocation at northern or southern latitudes of 32 kilometers. Why? Because when you project from a spheroid or an ellipsoid and you project onto a plane, you get different positions as indicated on this diagram. So what this means is that in any organization, you still need geospatial professionals to enable that enterprise to make sure that your navigation coordinates, your information, actually are correct. They are usable. And this geospatial foundation is provided by your hydrographic office, by your military survey, by your survey of India, and they provide the framework and they fill in the white space on the map that allow you to conduct your operations. So how do we achieve this vision? How do we increase collaboration, agility, responsiveness, and the adaptability we need to solve our national security problems? The first thing we do is we empower everybody. We give people access. We allow them to use tools. We encourage them to share, and we enable them to contribute. We do that by providing authoritative, current, and relevant information. Okay. We have to fuse the air, land, sea, space, and hydro information. It's not enough for the Navy to operate on their own, or the Army to operate on their own. In Asia Pacific, we deal with maritime operations, we deal with amphibious operations. We need a seamless environment. We also have to provide analysis. The real power of taking geo-information and turning it into geointelligence is enabling an analyst to conduct analysis, to derive information, to find patterns that are not immediately obvious. We actually have to do this now in a very flexible architecture, because when everything is nice and quiet like today, the systems don't have much demand. But the day there is a tsunami or an earthquake or a major terrorist attack, your systems will go down if they are not scalable and elastic to meet the demand. The cloud is nothing more than the evolution of information technology. The cloud is nothing special other than the next generation of information technology that lets us do this. But we have to harness these technologies, and if we want to ensure that our OODA loop spins faster than our adversaries, if we want to make sure that our decision making is better and faster than our adversaries, we have to stay up with the technology. So how are agencies achieving this? Is this just another statement of what we'd like to do? Well, let's look at one agency. Perhaps the largest geospatial intelligence agency in the world is the National Geospatial Intelligence Agency. You can download their strategy, You can look at how they're empowering their users. You can download the Australian Geospatial Intelligence Organisation, and you can look at their vision for online, on-demand, access to information, anywhere, any device, anytime. That's the vision that we have to provide. So from the foundation data management, we have to manage hydrographic data, topographic data, aeronautical data, open source information, human terrain, satellite information. And we have to bring that in to our systems. We have to manage that data, perhaps by its discipline, and we have to then publish that information through a data warehouse. And that data warehouse is then where our customers, our users, it's where everybody will go to then get that authoritative information. So when I was a NATO staff officer, we used to publish an op order, and we used to declare what were the authoritative products. We had lots of countries' maps to choose from, but we had to pick one. And we published that, we communicated that by publishing an op order, which said the 1 to 50,000 scale map you will use is the M709 series edition 3. Go to the map depot, get the maps, and fold them up, and off you go. That doesn't work today. What we have to do is provide online information in browsers where people can fuse topographic, hydrographic data, put onto that the operational overlays, and we have to give them all this information in tools they can use. Not in complex geographic information software like ArcInfo, which we make, but which is too hard for 99% of the population. This fused picture is essential for joint maritime multi-agency operations. But we still need paper products. It will be many years before we dispense with a paper document. So what we need is a data-centric approach. Not a product-centric, a data-centric. This is a database-driven approach where all of the geometry exists, but it is all attributed because it's a database. And from that, we can cut the production times and the costs. We can create products when we need them based on the latest available information. We can integrate with a variety of data sources. So let me just digress there. When the USS Eisenhower was about to make a courtesy visit into Bahrain, she knew she couldn't go alongside because they didn't have up-to-date information on berths. When there was an earthquake in Haiti, we couldn't send in our Marines and our logistic ships because the harbour had collapsed, the cranes had fallen in, the piers had collapsed. But what we did is we sent in our hydrographic surveys, and we did very quick hydrographic surveys. We electronically transmitted that data back to Bethesda in Maryland. We updated the hydrographic databases. We created a web service which published that information as a PDF, and they printed it on the USS Eisenhower just before she went into the harbour and docked, as opposed to standing off and ferrying everybody in lighters, or whatever the term is for small naval vessels. I call them boats, I apologise. The same with our Marines and our rescue effort in Haiti. They actually were able to come into parts of the port which were still usable rather than stand off. So now you have this concept of production on demand, print on demand. Okay? The cartography is actually done on the server. Okay, cartographers don't like that, but sometimes it's acceptable. The Canadians have taken examples, this map sheet here. They've taken a full military specification, 50,000 map. It took them 3 months to make, and they've taken a rapid graphic that took them 5 hours to produce. They've gone to the soldiers and they said, "Can you tell the difference?" And they said, "No, we'll use the 5-hour product." It's delivered as a PDF or an image. It's printed locally. Gone are the days of needing a map depot. The US Army has a Humvee which has 4 printers in it, and they can generate 400 or 500 maps for an operation within 4 or 5 hours. I want to look at 2 case studies. First one is NATO, the largest and most successful alliance in the world. They recognized for their net-centric operations, they had to support all of their command sites, including Afghanistan. Every location on this map is a NATO command headquarters. They all need geography. They all need foundation data. They all need to conduct operations based on that information. So their mission was to provide enterprise-level geospatial services using the same spatial and time frame of reference. So they had timely, accurate, and guaranteed information and services. I'm as a soldier, I can condense that to about 3 words or 4. Fight off the same map. Everybody had to fight off the same map. And I don't want to publish an op order. I want to give you that map, and I want to give you the tools to use it. So NATO's concept of net-centric warfare is called the NATO Network-Enabled Capability. It has common core services, web services. One of those is GIS, Geospatial Information, which is then provided as authoritative, online, on-demand information to their functional services, which are their air, land, sea command and control, their special forces command and control, their electronic warfare systems, their chemical, biological, radiological systems. So they're providing now not an op order with the directions, sort of maps to pull off the shelf, but they're actually providing that information as authoritative content directly into their command and control systems. Second case study I want to look at is the US Army. The US Army is the largest geospatial enterprise in the world, and it is a true enterprise. And what the US Army have done is actually regarded by Director Long of NGA as the best practice in how to manage a military geospatial enterprise. So what does the US Army geospatial enterprise look like? You can read that, you've got better eyesight than I have. So I'm going to simplify this diagram for you. What they do is the US Army takes national data sources, whether it's from the National Geospatial Intelligence Agency or their National Army Production in Fort Belvoir in Virginia. They take that information into their Army data centers in the regions around the world, into Central Europe, into the Pacific region, into the Southern Command, where they have Army data centers that continue to densify this information. They put that information into their Army command posts, in forward operating bases, in tactical operations centers, deployed with the force, mobile units. And that information then is fed and supplemented by Army sensors. So they're bringing in Intel ISR sources to supplement this, including mapping technology. And ultimately that information is provided down to the mounted and dismounted users. And by the way, it's got to come back, because every soldier is a sensor. How do they do that? I think this gets to one of the questions that the previous speaker had. They have a system, it's their Army intelligence system. It's called the Distributed Common Ground System Army. It's made up of a number of analysts, and you can see them all on the diagram behind me. Top of the tree is the all-source analyst, the person who supports the intelligence preparation of the battlefield, the environment, and supports military decision-making. That person is enabled by an imagery analyst, a human detector, a human analyst, a SIGINT analyst, an EW SIGINT voice interceptor, a cyber analyst, and a signals collector analyst. These are all the intelligence analysts that take the foundation data, add the intelligence on top of that, provide it to the commander for decision making, and then that information goes down to the mobile forces. So the guy I didn't talk about is this guy, the topographic engineer. It's what Todd used to be, it's what I used to be. These guys do not sit in barracks, they sit in the brigade combat team. They're the guys who maintain the foundation data. They're the guys who maintain the servers that provide this authoritative content. And reading the brochure for this conference this morning, there was an article by one of the retired generals on military GIS, and it is about taking this information onto the battlefield, not just as maps, but actually taking the databases and the servers onto the battlefield. The Brits have done it in Afghanistan. It was called Dataman. The Canadians are now standing these systems up. The Australians are standing these systems up. The Brazilians are about to modernize on this approach. This is how people take relevant information onto the battlefield. Why do they do that? Because they have to support everything from mapping to navigation, including targeting, including command and control. But there's somebody in that organisation who knows that one of our intelligence source was on Holland's Codal data. Well, one of them knows not to use Google Maps for certain latitudes because there are accuracies in the data. But that person knows not to combine two data sets because they don't match. So hopefully I've given you some ideas of the value of foundation data, its relevance to military operations, its relevance to navigation, and a vision that people are now implementing as to how you can do this across the force to support national security. Thank you very much.